Okay, so for this question, we do number A first. And for this reaction, we need to split it into two half reactions, which is SB solid turns into SB406, which is also solid. And the other half reaction will be NO3 minus, which is aqueous, turns into NO, which is gas. And we know it is in acidic solution. So first we need to balance the amount of SB, which is 4 SB here. And then we know that we see there's 6 more oxygens on the right side, so we need 6 oxygens on the left side. To achieve that, we add 6 H2Os on the left side. Now the number of oxygen is balanced, however, we have more hydrogens on the left side, so to balance that, we need some hydrogens on the right side. So we have 12 hydrogens on the left side, which means we need 12 H pluses on the right side. Now this half equation is being balanced, but the electrons are not being balanced. We know that there are 12 plus 1s on the right side, which means we need 12 electrons on the right side. Okay, so now this half reaction is actually being balanced. Now we go to the second half reaction. We can see the number of N is being minus, so we only need to balance the number of O's. So similarly, we add H2O on the right side since the left side has more oxygens. So we add 2 H2O on the right side. So now we have 3 O's on the left side and 3 O's on the right side as well. But however, we have 4 hydrogens on the right side, which means that we need 4 H pluses on the left side. Now the right side has a charge of 0, but the left side have a charge of minus 1 plus 4, which is 3. So we need 3 electrons on the left side. Now both of these half reactions are being balanced, so we need to add them together. But as we are adding it together, we need to cancel out the electrons, which means that we need to multiply the second half reaction by 4. And then we add the 2 half reactions together, and we get 4SB plus 6H2O plus 4NO3 minus plus 16H plus equals to SB406 plus 12H pluses plus 4NO plus 8H2O. And we see that we can cancel out H2O and H pluses, so there are 2 H2O and 4 H pluses, and we know that it is in acidic, so we don't need to change it from H pluses to OH minus. So this is what we get for the reaction, which is 4SB plus 4NO3 minus plus 4H pluses goes to SB406 plus 4NO and plus 2H2O. Now we are trying to identify the oxidizing and reducing agent. So from the first half reaction, we know SB here is 0. The oxidation number is 0. And for on the right side, we know that oxygen usually has an oxidation number of negative 2. And this whole thing add together has a charge of 0, which means that SB has a charge of 3 plus 3. So the oxidation number of SB increases, which means that Sb is being oxidized. And we know the concept that something that is being oxidized is a reducing agent. So we know that Sb is the reducing agent. Similarly, in the second half reaction, we know that O usually has an oxidation number of -2, and this whole thing, NO3 minus, has an oxidation number of -1, which means that N has an oxidation number of +5. And for here, the total oxidation number is 0 and O is -2, which means that N is +2. The oxidation number of N goes from +5 to +2, which is decreasing. So N is being reduced. So something that is being reduced is an oxidizing agent. And this is the answer of A of this problem.